Hi, I'm going to talk to you today about place value, rounding, and significant figures. So as usual, we'll start with a little math review. When you look at this chart, you'll notice that this is a chart of place values. So we have the ones, tens, hundreds, thousands on the left side of the decimal point, tenths, hundredths, thousandths, and so on the right side. That's important to know in case you're asked to round a number to a certain place. So when we're rounding numbers, we should always round up if the digit to the right of the number we wish to round to is 5 or greater, and we round down if the digit to the right of the number that we're trying to round to is less than 5. So here's an example. I want to round these two numbers to the nearest hundredth. So I'll find the hundredths place first. The hundredths place is the 0 in the first number, 5.304. The 0 is in the hundredths place. Then I look to the right of the 0, since that's a 4, I'm going to round this number down. Now, by rounding down, what I mean is I'll round it to the hundredth that is closest. My two choices are 5.30 and 5.31. Rounding down would make this 5.30. In my next example, the number is 0.088. The first 8 is the one that's in the hundredths place. This is the number that we look at to see if we round up or down. So I will round that up 0.08. My two choices are to leave it 0.08 or to round it up to 0.09. Since the 8 is in the thousandths place, that rounds it up. This rounds up to 0.09. Okay. It's your turn to try a few. We've got our little thinker cat. Her name is Scout. That's my kitten. Down there on the bottom left corner. So take a few minutes and try these. I want you to round these numbers to the nearest tenth. So you might notice I did the first one. I looked at the 0. 4 is smaller than 5, so I left that as 0, 432.0. Give you a little time to try the next two. And you can check your answers. The last one's kind of tricky. This 9 will make 2.9 round up. Well, what's higher than 2.9? 3.0. So I just want to say a note about rounding whole numbers. Sometimes I have a couple of students every semester who get a little confused when they round whole numbers. So when we're going to round these numbers to the nearest thousand, for the first one, I'll look at the 1. That means I'm going to round down. Now to round that down, we're going to round to 45,000. The mistake students tend to make sometimes is just round it down to 45. And if you think about it, that really doesn't make any sense. If I had a car that was for sale for $45,132 and I said, well, I really want to get rid of the car, let's just round it, and you say, okay, I'll give you $45, I don't think I'm going to sell you my car. The next one, we've got a 9 in the hundreds place. We want to round to the thousands, so this one would round up to 46,000. If that happened to be 49,950, well then we would round that up to 50,000. So in science, we use something called significant figures. The reason we use significant figures is because we are often in the lab using measurements, and it's really important that we record our measurements with the correct precision and accuracy, and our calculations with the correct precision and accuracy, so that other scientists can look at our lab reports and know what type of measurement tool we were using. So for example, if I took two measurements in lab and then I divided them and I got a number something like 0.0116236 grams when I divided those on my calculator, I probably wouldn't leave that whole answer, because chances are I don't have a scale that actually measures to this small of a place in grams. So let's say I have a scale that measures to the hundredths place. Then what I would do is, after I do this, I would round probably to the hundredths place, and I would end up just writing 0.01 grams. And that would tell other scientists that, hey, you know, this was the actual precision of the measurement, and we didn't have a scale that measured in any more precise than that. You can look on the internet, or you can look in your book, and you can find some rules for counting significant figures. Significant figures are sometimes also called significant digits. But what I want you to do, instead of memorizing a bunch of rules, is come up with some idea on your own about how we determine which digits are significant. So in this list of numbers, these are all measurements that were taken in the lab, and they contain what we call significant digits or significant figures. Look at this list of numbers, see if you can determine which digits are significant and why. See if you can create some kind of rule that would tell another person how to determine what a significant figure is if you're only given a measurement. Give you a little time to think about it. Any ideas? Okay, here's the deal. If you look at these numbers, notice that the zeros in front are not significant, and the zeros at the end of the number are not significant. So in a decimal number, the zeros in the beginning of the number don't count as significant. In a whole number, the zeros at the end of the number typically don't count as significant. If you have zeros behind a decimal point, though, with numbers in front, they are significant. Okay, we're going to go to the next slide and see if we can figure out how to count significant figures. Okay, so I'm going to try the first one for you, and then I'll let you do the rest on your own. When I look at the first one, the 3 and the 5 are significant digits or significant figures, so there are two significant figures in this measurement. The zeros don't count as sig figs because they're considered placeholders. If I would write this number in scientific notation, I wouldn't write those zeros. I would simply write the number like that. So only the 3 and the 5 are significant. There are two significant digits here. Go ahead and try some of the rest of them. And I'll bop around like this once in a while, just so that you know that I'm still here and you should still be on the same slide. And that the recording hasn't quit. Did you get them right? In part B, all the digits count as significant because this 0 is at the end of a decimal number. It's not the leading zeros. So leading zeros in a decimal number, a number less than 0, are not significant. Okay, so those 3 zeros are not significant, but this 0 and this 0 are. Any number is always significant, 1 through 9. Those are always significant digits. It's the zeros you have to watch out for. So in part C, all 4 numbers are significant. In part D, all 3 of these numbers are significant. We don't worry about the 10 to the 5th power. We'll talk about E in a minute. In F, because there's a decimal point here and the zeros are behind the decimal point, they're not in front as they were in A. We've got 5 significant figures. All of these are significant. And in part G, we have 1 significant figure for sure. Depending on how precise the thing was measured, we may have more than 1. Now, what do I mean by that? Well, you know, let's say you were measuring a big football field and you measured to the nearest 100,000 feet or something. You had a big, huge tape measure that was only measured in 100,000, that was only marked in 100,000 feet. Then that 1 would be significant. It's really hard to tell in a number like this how many are significant. We'll say that there's 1 sig fig there, but if the number was written like this, which is actually equivalent to 100,000, then this number has 3 significant figures. So we often write numbers in scientific notation so that we can determine how many significant figures there are. The reason I put a question mark at E is because E is what we call an equivalency, and it's an exact amount. And exact amounts have basically unlimited numbers of significant figures. So let's not really worry too much about that one for right now. We just say that it has an infinite number of significant figures, which is really kind of silly. It has 12 if you count the dozen. But hopefully that gives you a little bit of a feel for how to do significant figures. So the place we'll be using significant figures in class is in lab. I'll always want you to record the correct number of significant figures in lab. And when you're doing your homework and you're doing calculations in your homework, then it will be important that you round your answer to correct number of significant figures. So if you look at these two examples, one's a multiplication example and one's a division example. When you're multiplying and dividing, you should round your answer to the same number of significant figures as the factor that has the fewest significant figures. So when we look at these numbers, this first number, 5.02, has 3 significant figures. 89.665 has 5 significant figures. 0.10, this 0 doesn't count as significant. It has 2 significant figures. So the fewest sig figs is 2. That means we want to round this answer to 2 significant figures. Well, if we're going to round it to 2 significant figures, here are our 2 significant figures. The 0 is past 2. That would be the 3rd significant figure. We want to round it to 2. The 0 tells us that we would round this down, and our answer would be 45. Okay, in the next example, we're doing a division problem. Again, we're going to round to the least number of sig figs. This number has 4 sig figs. This number has 3 sig figs. The 0 does count because it's to the right in a decimal number. We want to round this number to 3 sig figs. So to round this number to 3 sig figs, here's 1, 2, 3. Don't count the 0 in front. The 9 makes that 5 round up. So my answer is 0.966. Notice I leave the 0 in front when I'm writing decimal numbers, and if you're going to be a nurse or any kind of medical practitioner, that's quite important. You could imagine that if you had a number on a chart and it was 0.5, and if you didn't write the 0 on here, it would be really difficult for someone reading that to know if it was 5 or 0.5. So that's why we always include the leading 0 when we write decimal numbers. So multiplying and dividing, we round to the least sig figs, but when we're adding and subtracting, it's a different rule. When we're adding and subtracting, we just round to the least number of decimal places. So if you look at the first example, example A, the first number has 3 decimal places, 3 places to the right of the decimal. The second number has 1 decimal place, and the third number has 2 decimal places. We're counting the decimal places to the right of the decimal. So when we add this up, we get 124.867. We want to round to the least number of decimal places, which would be 1. And notice if you were doing this by hand, you could put a nice little line there and it would show you where to round to. If you're doing it on your calculator, you're just going to know that you round to 1 decimal place. The 6 makes the 8 round up, and so you would get 124.9. On the next one, we have 3 decimal places, 3 decimal places, 2 decimal places. So I'll round my answer to the least number of decimal places, which is 2. Negative 8.664, the 4 will round down, leaving our answer as negative 8.66. When you're doing a problem that has multiple steps, what we do is we don't round anything until the end. We underline the place that we would have rounded in each step, and then we don't round until the end. And remember, with multiple steps in math, you have to please excuse my dear Aunt Sally, in that we do parentheses first, then exponents, multiplication, division, and we do multiplication and division together in the order that they come, and then our final step is any addition and subtraction in the order that they come. So in this problem, we have to do the parentheses first. So we'll do 5.67 minus 2.3. That gives us 3.37. You can plug it into your calculator, try it. Now, that's a subtraction problem, so I should round to the least number of decimal places, which is 1 decimal place. So then I underline the 3 to say, hey, I should have rounded this number to there. I'm not going to round it to there. I'm going to leave the answer full in my calculator, but keep in mind that I should have rounded that to the 10th place because that was the least number of decimal places in this part of the problem. Okay, next step is to multiply the answer that we got, the 3.37 times the 3.489. When you do that, you get 11.758. Now, when we do that step, we want to round this one to the least sig figs, to the least number of significant figures that we had in these two numbers. Just to remind you, this we should have been rounding to the least number of decimal places, which is why I underlined the 3 here. So pretend we had actually rounded the 3.37. If we had, it would have had 2 sig figs. We would have rounded it to 3.4 if we wanted to stop with that part of the problem. So that would have had 2 sig figs. We didn't do that because we don't want to throw our answer off. 3.489 has 4 sig figs. Well, 2 is less than 4. 2 sig figs is what we want to round to. So when we round 11.758 to 2 sig figs, that means we're going to round it to right here. It means we have to look at the 7 to see what happens to the 1. So it's 11.758. We want to round it to either 11 or 12 because that would be 2 significant figures. The 7 makes it round up to 12. I hope this was helpful. I tried to use examples from all of the Mastering Chemistry problems that are in the Dynamic Study module titled Key Math Skills, Significant Figures. Thank you for your time. Have a good day.